Hi all. Let's go through the third problem from perspective projection. A cube of side 25 mm is kept with one of its square face on the ground with one of the vertical edges touching on the picture plane. All the vertical square faces are equally inclined to the picture plane. The station point is 35 mm from the picture plane, 10 mm towards left of the center of the cube, and 45 mm above the ground. Draw the perspective view of the cube. So the details of the object and station point is given in the question. Here the object is a cube with a side 25 mm. You have to focus on the object. Object is something similar to a prism because it is a cube, which means it has a bottom surface and a top surface. Total 8 corner points are there and 12 edges. 4 edges on the bottom surface, 4 edges on the top surface, and 4 vertical edges. It is given that one of the vertical edges is touching on the picture plane and the vertical square faces are equally inclined to the picture plane. First we are drawing the PPP line, that is the first step. Then we are drawing the plan of the cube. Since all the vertical faces are equally inclined to the picture plane, the cube will appear like a diamond like shape in top view. So you have to draw the PPP line, then draw the top view, and one of the corner points of that square or diamond shape will touch the PPP line because it is given that one of the vertical edge is touching on the picture plane. Let's draw the PPP line and the top view of the cube. First we are drawing the PPP line, then you have to draw the top view of the object. So it will appear like a diamond like shape. You can take one point here on the PPP line, then it is inclined 45 degree with a PPP line and the side length is 25. Here also it is 25. So this is the top view of the cube. There are 8 points, you can name the points now. These are the 8 points. Top surface is A, B, C, D and bottom surface is E, F, G, H. Now to draw the front view of the cube, you have to draw the EGP line. Draw the EGP line. You can take some random space. You can take 10 mm or 15 mm above the the top point of this top view. From this point you can take 10 mm. So assume that distance, then draw the EGP line. This is EGP. Elevation of the ground plane. Now you can draw the projection lines to get the position of the front view. Position of all the points in front view. So just draw the projection lines like this. And in front view, the cube will appear like a rectangle. You can take the height of the cube. Height is 25. So from this point I am taking 25. So it will appear like a rectangle in front view, and you can see the center line. And you have to mark all the 8 points in the front view also. So this is the front view of the object. We marked all the 8 points. Now you can represent the mark the dimension lines. Just mark the dimensions. It is 25. Here also it is 25. Okay, and after marking the front view and the top view of the object, you have to draw the central plane. It is given that the central plane is 10 mm towards left of the center of the cube. So it is this one is the center of the cube. From this point it is 10 mm towards left. So I am going to draw the central plane now. See the position of the central plane. It is 10 mm towards left of the center of the cube. Now you have to mark the station point. It's given that station point is 35 mm from the picture plane. So it is 35 mm in front of the picture plane and 10 mm towards left of the center of the cube and 45 mm above the ground. So small letter s is 35 mm below PPP line and the s dash is 45 mm above EGP line. So let's draw s dash and s. S dash is 45 mm above 45. So that is point S dash. Similarly, small letter s is 35 mm below. So that will give you position of small letter s. Let's mark those lines, those points. This point is s dash. And this one is small letter s. So these are the points. Now you can draw visual rays connecting this point and all the corner points of the cube. So you have to draw 8 visual rays in front view and 8 visual rays in top view. Now draw the visual rays in front view like this. From S dash we are drawing lines to all the corner points. Total 8 points are there, but 6 points are visible in front view. We are drawing 6 visual rays like this. After that you can draw visual rays in top view. Okay. Now we need to find the intersection points of the visual rays in top view with the picture plane. See, the top view is somewhere intersecting in the picture plane. And we have to draw projection lines from those points. So I'm drawing projection lines from these points. This one is point A. See the intersection of point A. A is intersecting here, and from here we are drawing projection line to the visual ray A dash S dash. So that is capital A. Similarly, we can draw all the projection lines from the intersection points. So second intersection point is here. From here we are drawing projection line. So you will get capital E here, capital A here. Similarly, we will get a capital F and capital H. Sorry, capital D and capital H. See, by drawing like this, we'll get 8 points: A, B, C, D, 4 points on the top surface, E, F, G, H, 4 points on the bottom surface. If we join them together, we'll get the perspective of the cube. So you will get a 3D picture. Some lines are visible, some lines are not visible. You can draw the outer lines using continuous lines. So you can darken that portion, and inside points are there. Point B and point H is inside. So we can draw dotted lines connecting point H and all other points in the bottom surface. Since one point is resting on a picture plane, BF is it is not a point, it is actually a line. It will appear like a point in top view, but that is a vertical edge. So BF line is completely visible. We can draw the vertical edge like this. So now I am joining them, the continuous lines connecting the corner points, boundary points. So these are the points in the boundary. Top surface is visible because see the height of the station point. If the station point is this much high, then it is visible. This line is also visible. Only one point is not visible in the front, that is point H. So you have to draw dotted lines connecting point H and all other points. So we can dot dotted lines to draw them. So we are connecting dotted lines between H and E, H and D, and H and G. So this is the 3D view of or real-time view of a cube. See the difference. So if the observer is 45 mm above the ground plane and 35 mm in front of the picture plane and 10 mm towards the left, you can see the cube like this. This is how we are drawing the perspective of the cube. Thank you.